Hi, this is another IoT Tech call in the summer edition. I'm Stefan, I'm the developer ecosystem for Cumulocity. And today I want to talk about machine learning in Cumulocity. And I have invited two amazing guests, which hopefully can introduce themselves. Maybe Kanishk, you can start introducing yourself.
Yeah, sure. Thanks, Stefan. My name is Kanishk Chaturvedi. I'm a solutions architect, and I've been working with Cumulocity for the last 2 years. And here I'm part of its IoT and analytics business unit, and I specialize mostly into the topics of IoT and AI. So within AI, not only traditional AI, which are usually machine learning or deep learning models, but also modern AI, which is generative AI, which is also a very hot topic these days. And I have an education background in computer science, and I did my PhD in geospatial technology. And before joining Cumulocity, I used to work as a consultant in the field of smart cities. And there, I worked on different smart city projects with, for example, City of Munich, London, Hamburg, and many more. So yeah, this is just a quick info about me.
Okay, thank you, Kanishk. Nick, over to you.
Yeah, thanks, Stefan. So my name is Nick van Damme. I'm the product management team lead for analytics and AI ML at Cumulocity IoT. I joined Cumulocity, I think, 3-4 years ago from sister company Transminer back in the days. My background, I graduated as a mathematical engineer from the University of Leuven, let's say, think roughly 15 years ago. And then I started my professional career as what they would now call a data scientist. But then after some time, I rolled into product management as I felt that I wanted to improve the tools that were available for me at that time to help out my work and the customers that I worked with. And this is after a few other companies brought me to where I am now with Cumulocity, where I'm supporting our customers to ideate on the possibilities for AI and machine learning and analytics in general, I would say, to enhance the capabilities of their IoT applications and offerings.
Okay, thank you, Nick. That's actually a good point for the next question. I think you covered or something, some parts already. So what's your background with machine learning and Cumulocity? I think you already covered some of them, but maybe you can dig in a little bit more. Kanishk, you said you have some experience with smart cities and machine learning, but maybe you can give much more, a little bit more detail about it.
Yeah, sure. So maybe I can start with the experience with machine learning. So earlier, as I mentioned, I come from smart cities background, and in that role, I was responsible for developing what is known as urban digital twins. So what does that mean? So that basically involves, first of all, creating geospatial data or 3D models of city infrastructures like buildings, streets, flyovers, and so on. And the second stage is connecting real-time data from sensors or IoT devices to these 3D models. So for example, you can imagine smart meters in building rooms or traffic sensors installed at street intersections. So this integration basically allowed real-time replicas of city objects in terms of mostly how its properties like energy use or traffic flow is changing in real time. So this is about the real-time replica. And once we have this replica, then as a next step, we take these real-time models and enhance them with machine learning models for deeper analysis. So for example, you can imagine by analyzing past energy use and including weather trends, we can predict a building's energy demand for the coming week or for the coming month and so on. So in that way, these digital twins or urban digital twins are being used by many cities these days for detailed analysis, simulations, and performing what-if scenarios. So that's how, as I mentioned, I was already familiar with the integration of IoT data and machine learning models. And 2 years back when I joined Cumulocity, Nick was already exploring this topic. So that's how we joined forces for this task.
Okay. And would you also consider yourself some kind of, like Nick said, you were part of a data, you fulfilled the role of a data scientist, or did you created actually machine learning models in the past?
Yes. In the past, depending or based on the specific requirements, it was one of the roles to find out which algorithm should we apply for this particular problem. So, and also we used different types of frameworks. So yeah,
Yeah.
I have some knowledge before joining Cumulocity about creation of the right machine learning models for the specific use cases. Yeah.
Okay. Over to you, Nick. You also covered that you have you were in the role of a data scientist, and then you want to move at the product management and want to discover more on the tool side. Can you give a little bit more details, what kind of tools and machine learning models and use cases you have worked in the past?
In the past, the company that I worked with was mainly focusing, let's say, on manufacturing and doing more with the data which was there in manufacturing. So it was about optimizing a manufacturing process, trying to increase the yield, the output of certain process steps, trying to do a kind of influence factor analysis, like I have this certain deviation in my machine, in my production line, and what of the parameters around it, kind of machine settings or inputs like the material inflows, etc. How are they perhaps influencing the fact that I have some certain deviations in terms of yield or quality, etc. at the final stage of my production line? So those were mostly kind of projects that I was involved there. And now with Cumulocity, I really take it from, let's say, the product management angle. I talk to customers and try to understand how they would like to leverage analytics and machine learning for their use cases, and then take that back into the product and see, like, how can we make it work more seamlessly together? How can we make machine learning and Cumulocity work together in a good way for the sake of the use cases of our customers?
That's maybe a good point to talk about how machine learning and Cumulocity is working together. Can either of you give a short introduction for the people or for the audience? What capabilities or analytics and machine learning capabilities we have with Cumulocity, or maybe the history of analytics and machine learning with Cumulocity, maybe?
Sure. I think maybe before diving into really machine learning and Cumulocity, maybe it's good to repeat, like, it's important to understand that there are two phases in let's say the life cycle of machine learning. And it's on the one hand side, it's about training a model. You have a set of training data, preferably a lot of training data that you get from your IoT sensors, and then the focus is on finding the right model for the task that you're being given. For example, predict a certain output or try to identify anomalies, etc., etc. And then you want to find, not just one model, but maybe compare a number of models, see what the best model is. And then you have a certain model of, let's say, a trained model, which is then set out to do the task that you want it to do. On the other hand side, when you just don't want it, let's say, lying around. Your job is not finished when you have created a model. You also want to take advantage of the fact that you have built that model and apply it to newly incoming data. So that's where you also, and that's, let's say, the flip side of the coin for machine learning model. For machine learning, it's about putting that model to practice on new data which has been unseen. That's where you have kind of bit that differentiation between a lot of compute power to train a model, and then continuous inferencing, as they call it, on new incoming data. And if you then look at it from a Cumulocity perspective, I think on the one hand side, if you want to train a model, you need a lot of data. So it's making sure that you make that data that is there, that you've captured from your IoT sensors, and make that available to the toolset that you want to work with to create that model. And that's where, for example, our Data Hub application comes into play, which allows you to easily offload the data, but also query that historical IoT data that you've gathered and make that available to a data science workbench with which you build your machine learning model. Mm-hmm. If you're talking about the second stage, it's about the inferencing on real-time incoming data. Then, of course, with Cumulocity, you have easy access to that incoming data. And then you need to look at how can I make that incoming data available to my trained model to get, again, a kind of prediction and output of your model. And that's where then some technologies like our streaming analytics can come into play to really bring that data, that new incoming data, to the model. And then also, again, when you have the result of your model, do something with that result. And that can then be, for example, I don't know, create an alarm when it's outside of a certain expected bound, or trigger a kind of workflow in an external system, or maybe even trigger an operation in the device from which the data is coming, using some of the Cumulocity IoT capabilities.
Yeah, if I got it correctly, the first part is actually to train a model. You first need to collect the data, and I think this is what Cumulocity is made for. You can easily harmonize the data of your devices, of your assets, collect the data, offload the data even to a third-party data lake using the data hub, and then you can do some discovery. And this is where some data scientists will do some discovery in that data, building a model, training a model, and then you have a model. And then the second part, as you said, is taking that model, executing it on real-time data, not maybe on the trained data, and see what is the output of the data. And then you will start the whole process over and over again. And so it's a circle, some kind of, if I got it correctly, that we then have maybe another training set, train it again, have another model, another version of the model, deploy it again, and improve that model more and more and more. Yeah, okay. From a tooling perspective, what would you say? You already mentioned already, we have the data hub there, we have streaming analytics, there's Apama. From the machine learning perspective, for the training part, what would you say? How can that work with Cumulocity? Do you suggest any third-party tools for the training? Did we had? I think in the past we had something which we discontinued. Anything you can suggest people can work with, or suggest from a Cumulocity perspective how to train your model? Or is it, say, we are working with everything, I don't care?
Yeah, I think it depends on the approach that we would like to take for, first of all, training the machine learning models, but also deploying the machine learning models. So, for example, one possibility could be that machine learning can be deployed on hyperscalers like Amazon SageMaker and so on. So Amazon SageMaker already provides the right tooling for training, for also deploying the machine learning models, which also establishes the right endpoints that can be used for performing inferencing and so on. So that's one approach that hyperscalers can be used for creating or training the machine learning models. There are also some approaches when the models needs to be deployed as Cumulocity microservice or maybe as part of edge devices. So for that, there are some open source toolings, for example, Onyx, Open Neural Network Exchange. So Open Neural Network Exchange, Onyx, the advantage is, first of all, it is completely open source and is interoperable in nature. So that means users can train their models in various frameworks like TensorFlow, PyTorch, scikit-learn, and so on, which can then be easily converted into the Onyx format. So in the end, there is only one machine learning engine, which is called Onyx Runtime. It can be used for working with different types of machine learning models. And so as I mentioned, there can be different types of toolings based on what approach do we want to use together with Cumulocity.
No.
Maybe Nick, if you have.
Yeah, I think you can go very broad. Like we said, with Data Hub, you can offload your data into a data lake. And basically, you could have any tooling just working right from that data lake, from the data set in the data lake, and get started with it. Data Hub is also very much suitable to query the data using SQL. And so any kind of tooling, any kind of data science workbench tooling that can do SQL queries to an external data source would very much be up to the task to get the data. And then of course it's up to the tool set, and then it's of course up to the user to take advantage of the tool set of the data science workbench. And there the sky is the limit, of course, because in this day and age we have a very large variety of data science vendors out there, ranging from, like Kanishk said, hyperscalers with their solutions like an Amazon SageMaker. You have Azure Machine Learning Studio, but you also have the likes of Data IQ, RapidMiner, Altair, etc. So there's a very wide range of tool sets available, either like the commercial ones that I said, but also open source libraries that you can just, if you're a favor of the more of a pro code approach, you can just get started with R, with Python, and have some kind of, for example, Python notebook tooling, etc., to get you started for training the model. And then afterwards, like Kanishk said, once you have the model, it also depends a bit, like, what do I actually want to do with it? How do I want to integrate it with Cumulocity? And that depends a little bit on the kind of use case that our customers have in mind. Is it okay to have it in the cloud? Then perhaps if you use Amazon SageMaker, they have a capability to deploy your model, make an endpoint available, and then we can very easily integrate from a Cumulocity perspective by calling out to that endpoint, sending the new data to that endpoint, get the result back, and get that whole flow working. In other occasions, we can have other types of tooling just also can make endpoints available, which we can integrate then with for the purpose of the inferencing of the machine learning model based on new incoming data. So I think, in terms of tooling, the sky is the limit.
I think what I take away is we are very open. We have kind of an tool ecosystem, and we are open for the tools that can be used. So the data scientists and our users of Cumulocity have the freedom to choose how they want to create the model somehow, or how they train the model, and then how and where they want to deploy the model, and how to integrate the data back to Cumulocity.
Exactly.
Yeah.
Okay. Let's take a step back. You mentioned two use cases already in your introduction. One of you mentioned Kanishk was smart home use cases. You mentioned, Nick, some production use cases. In your opinion, what are the most common machine learning use cases you see in combination with Cumulocity?
No.
Mm-hmm.
Go ahead, Kanishk.
Okay, maybe I can start. So maybe one use case which is quite significant these days and in the news is predictive maintenance. So for example, by analyzing data from machinery, these kind of machine learning models or sophisticated models, they can anticipate failures before they occur, because this is very crucial and important, and it can be helpful for minimizing downtime for the machineries. So this is one use case. One use case could also be, for example, energy management. So again, machine learning models, they can learn usage patterns from the past. They can optimize energy consumption by learning those kind of patterns. And by this combination, they can also predict peak demands in the coming days, coming hours, and so on. So this can also be quite important. What else? Maybe anomaly detection is also quite an important use case when it comes together with IoT relevant or IoT devices. So anomaly detection models, they can help identifying unusual behaviors in IoT devices. So this is also quite important. They could signal security breaches or system failures and so on. Yeah, so I think these three are quite important. Maybe Nick, if you want to share?
I would also say like predictive maintenance is the most common use case that we come across. Also given our many smart equipment maker customers that we have, because that really allows them to do that proactive kind of detection of what is the operating status of my equipment? Is something going wrong? And in that sense, also proactively engage back with their customers. And then you have techniques like anomaly detection or real forecasting. I think the other ones also resonate. One nice use case that I think is perhaps maybe not that common yet, but I think will become much more widespread going forward, is also looking at vision AI. And so using cameras to detect, to identify certain objects, to identify certain patterns or movements which are abnormal, and based on that trigger certain reactions, etc. And so we have one customer who's really using that for their unique use case on insect control, on pest control, where they try to identify insects and the species of insects, and based on that trigger certain flows or perform certain use cases.
So you can say if it's a mouse or a rat or some bug which is actually in your trap.
To distinguish between unharmful and harmful insects, which can have effects on your use case or the kind of product that you're harvesting or the kind of product that you're maintaining in your silos.
I can also remember very interesting predictive maintenance, which was also where cameras were involved. And the use case was that they attached a camera on some, I don't remember the machine name or what it was, but it was a machine, and there was some, mechanic process happening, which is actually it was. There was a hole which was shut down, and then it was open again, shut down, open again, shut down, open again. And the maintenance part is that it's not fully shut, because there are some, stuff in there which is then prevent the machine from fully shutting the door. And then they installed some camera there and implemented a machine learning model, and saying to detect if there are some stuff happening, if it's the speed how the door shuts, if there are some working with a very nanometer or millimeter gap maybe, and then predicting that the maintenance should happen now until the door is not shutting at all anymore, and then prevents your machine not working for a full day or something. I think I can remember that. And we also used the machine learning model, which was trained on that metadata of that video stream, saying, detecting, now the door is fully shut, it's not fully shut, and this is the centimeters which is not shut, and then important that data to Cumulocity, and then in Cumulocity we create an alarm, typically saying, now the model calculated the maintenance should happen in the next 3 days, otherwise with a score of whatever, the machine will stop working, something like that. I can remember. And this is, I would say, it's a very typical predictive maintenance. It can be camera, it can also be some sensor status saying, and then having some sensor data saying, now the sensor data is behaving some strange, maybe you should start your predictive. And with predictive maintenance, always a process is involved. Now, I also saw a lot of customers implementing some basic process in Cumulocity, that you have a status saying, now I have some kind of alarm, and then this alarm then must be, I need to assign a worker on that, and the worker need to do the maintenance, and when the maintenance is completed, then I reset that everything, the alarm and everything. So this is, I would say, a very common use case also in my experience.
No, exactly. And I think in general, it's what I feel is it's AI or ML, it's not the end goal that you want to reach. In the end, analytics and all of that, it's to support your use case. It's to make your use case much more smart, where in the past you might not have had all of the signals available or the tooling available to do something automatic, but with analytics, with machine learning, you now have the tools to make your life more efficient, to make it possible to detect certain deviations just automatically without having to monitor something manually, like the video stream or something else. But now just with an image, have the machine learning model identify normal or abnormal, and based on that, you've automated your use case. You made your use case much more smarter. And I think that's where the way of thinking that could be beneficial for our customers to really think about making my use case smarter.
Yeah. And in the end, also saving costs is, I think, the most important. They're investing some time to, collecting the data, having some machine learning model, but in the end, they can save a lot of cost in that regards if you can remember maintaining the machines when it's actually too late. Yeah.
Exactly.
You already covered somehow that it depends on where to deploy the model. What kind of options do we have to deploy the model? Cumulocity obviously is one. Then you said AWS SageMaker. What about Edge? What options do we have to deploy a machine learning model?
That's something currently we are also exploring. So as I mentioned, one option is hyperscalers. So that has certain capabilities. For example, hyperscalers already have these scalability and MLOps capabilities and so on. The other option, as I mentioned, was the model can be deployed as part of Cumulocity microservice. So its advantages, first of all, it can enable low latency. It can also have enhanced data privacy. So for example, when we communicate with hyperscalers, we usually have exposure to those hyperscaler endpoints and so on. But in that case, model is part of Cumulocity ecosystem. So that means inferencing is happening within Cumulocity. And for that part, basically, we explored this Onyx model, which is an interoperable standard that I mentioned earlier, because it's lightweight. And for the edge devices, we are also exploring how Onyx can also enable that particular use case. So because edge devices, models can be deployed on edge devices, and it has certain capabilities or advantages, like the processing can happen closer to where data is collected. It can also reduce response time, minimize bandwidth use case. So for that, it's really important to have some kind of models that are lightweight, first of all, and which are also, perform inferencing with the same quality or comparable quality that we have on the cloud. So in that case, Onyx is quite useful because, first of all, you can convert any kind of models to the Onyx format. But I think its biggest advantage is the model quantization. So what happens is Onyx models or Onyx format, it allows models to be compressed and optimized for inferences on these lightweight or resource constrained devices. So that means the same model that we are using on the cloud platforms, they can also be used by quantization on these resource constrained or IoT devices, which is quite beneficial or useful for edge relevant use cases. So that's something currently we are exploring. And maybe in the next few weeks, we should have some update on that.
Okay. And can you elaborate a little bit more when I should deploy my machine learning model in the cloud and when I should maybe deploy it on the edge? I can remember, for example, that we have a lot of data, sensors creating a lot of data, and not everything should be sent to the cloud. And that's for Cumulocity perspective. We have multiple deployment options. We have the Cumulocity Cloud, we have the Cumulocity SIG Edge, and we have things like the Syn Edge, which is software which is running on Syn devices. And I would like to understand in which use cases I would say not everything is sent to the cloud. Then of course it will be very heavy, and a lot of data will be then which is not necessary in the cloud. And there may be something we have just on the SIG Edge, maybe you have something in Syn Edge. So this would be, I would say, good to understand if there is when to use what in machine learning use cases.
Yeah, yeah. I think, like you said, it depends a bit on the use case that you have at hand. If you have a use case where for your machine learning model you need a lot of data, then
Yeah.
typically typically you don't want to send a lot of data towards the cloud, towards the tick edge or the cloud, because it will also incur your costs. Then you want to shift it left, shift it down as much as possible, and make that do the kind of processing at the level of at the lowest level possible, closest to the source, I would say. Of course, there it also depends. Like, can I execute that model because of the resource constraintness of my device? Yes or no? Or how far in the, let's say, hierarchy should I shift it to do the inferencing? Other times, it also depends on, I think, Kanishk, you mentioned like privacy. Sometimes you don't want all of the data to come towards the edge, and maybe certainly not to the cloud. And there you want to have the processing as much as possible at the level of the device itself. You don't want to send, for example, a video stream to the cloud when the only thing that you want to detect is whether, let's say, a certain car is parked in a specific space. Then you just want to have a 0 or 1 being sent to the cloud, because that's the information that you're interested in, and not the continuous video stream. So I think it's important from a customer perspective. Always think about that trade-off between the cost of the data being sent to the cloud versus the latency also that is important for your use case, versus privacy requirements, etc. And that will depend the best place to deploy the model. And in the end, like Kanishk said, thanks to those standards like Onyx, it is now possible to have a similar model deployed at the cloud, at the edge, at the thin edge. There's a lot of advances in these areas to make customers really optimize the deployment location of their model, taking into account the constraints or the restrictions that they have for their use case.
Okay. Initially, we talk about training the models. Let's talk about that again. And would you say that I can remember for myself, I saw some other tools in the past saying, okay, claiming you don't need to be a data scientist to use that tool to train your machine learning model. In your experience, if I would a customer of Cumulocity and I want to train my machine learning model, do I need to have a data scientist team to do so? Or what options do I have to create or train my machine learning model?
Okay, maybe I can try to answer this question. So, in my opinion, it's important to have certain knowledge about data science. The reason is every machine learning model is created in a different way. So, for example, when we talk about anomaly detection model, that is completely different from an image recognition or image or activity recognition model. So the general workflow is you need to prepare the right data set and apply the right algorithm. So for example, in anomaly detection, algorithms like isolation forest are used. For activity recognition or image recognition, convolution neural network or deep learning networks, they are preferred. So here I actually read about a very interesting theorem. It's called no free lunch theorem. It is quite popular in the machine learning world. And it states that no one algorithm works best for every problem. And we must choose and tune our algorithms very carefully based on the specific task at hand. So that's why, in my opinion, it's always good to have data science relevant knowledge to make sure that we are applying the right algorithm with the right hyperparameters to that particular model development. Regarding your second point, you mentioned that some tools claim that you don't need to have data science knowledge. It is true at a certain extent, but still it's required. So for example, as I mentioned earlier, there are many advanced frameworks like TensorFlow or PyTorch. So these platforms already provide high-level functionalities or which can enable or help also beginners, but also experts to develop and deploy models. So that can be used to familiarize ourselves very fast for the machine learning training process. In addition, there are also some no-code tools. So for example, we explored earlier this Amazon lookout for equipment, or IBM also provides one tool which is called Auto AI. So they can already be used for some use cases like anomaly detection. So there you just have to add the relevant data for training, and without writing any code, it can use the right algorithm and it can train the right model for you. So yeah, these highly advanced tools are already available in the market, but still changing the right parameters or making sure that it is performing with the highest accuracy. It's important to have a very basic knowledge of data science for these use cases, I would say.
Yeah.
Okay.
You know the saying, a fool with a tool is still a fool. It is true, but having said that, in the 15 years since I've graduated from university, and well, when you think of university, it's really about you need to have deep knowledge of all of those things. Back in the days, it was really needed with AI and machine learning as well. But in those last 15 years, I've seen a lot of evolution in all of those kind of toolings, and making it available for not just data science experts, but also more for domain experts, and having the domain experts work with low code drag and drop tooling. It is these days omnipresent in all of those data science workbenches, and the really good ones have an easy option to switch between a pro code interface and a drag and drop tooling interface, and in that way they can also, let's say, abstract some of the difficulties away from towards domain experts, and make it really much more easier for domain experts to also get started with AI and machine learning. And then the other thing that I also do see is that we are now just talking in general about AI and machine learning, but you could use AI and machine learning for such a wide variety of use cases, ranging from what we said, like predictive maintenance, but also towards fraud detection, towards I don't know, insurance, for insurance purposes, for healthcare purposes, etc. There's such a wide variety of use cases that it makes it more difficult to make something special. That being said, so what you also see on the other hand side is that you have toolings very specifically just for one use case, where it's maybe just about anomaly detection, or it's just about vision AI, etc. And because you're narrowing down the focus on just one use case, you have a lot of more information, you have a lot of more metadata to fine-tune that process also for the sake of domain experts. You can make some trade-offs on behalf of the domain expert, because you know the specific application that you're building the AI and the machine learning model for. And in such a way, it's also much more accessible, and you can, those tools really abstract away the more difficult choices for the end user, and in such a way make it much more easier these days to have access to machine learning and AI models, and to do the job of a seasoned data scientist.
Do you see smart equipment makers offering some kind of machine learning service to their customers, that they invest the time with the data scientists saying, I offer you the hardware, I offer you the machine, my smart equipment, and I offer you a machine learning service with my pre-built machine learning model, and you can just deploy it to your production state or whatever, or where you have my camera deployed, my camera will work out of the box for this specific use case. Do you see that already?
We have some customers where, let's say, they make their services more smart, where it's not just about having the device or having the machine connected, but where they also give something back to their customer in terms of there isn't kind of an AI or machine learning model running in the background, which then signals to the end customer, hey, dear customer, you're not using it optimally, or your performance is starting to degrade, or you're in need of thinking of it, the predictive maintenance use case, probably within the next 10 to 20 days, you might need to do some maintenance or this on this or this kind of piece of your equipment. So I think it's not necessarily making, let's say, data scientists available, but really making some smart applications available to the end customer.
Yeah, I think this is different, that you offer some kind of service which can be customized on a specific customer process, but you don't have to go the whole way, with the data scientist exploring the data once again, training a new model once again, but customizing something which is already existing, if possible. Kanishk, anything you wanted to say?
No, I think Nick has already covered it. So yeah, so I'm currently not aware if any smart equipment manufacturer is already offering these kind of combined machine learning engine or model capabilities. In some cases, they work with partners, which allows to use their devices to work with a certain software which can enable these anomaly detection or image recognition capabilities. But yeah, I mean, I'm not aware currently of any one single house capabilities from any manufacturer.
Okay, then let's talk about future use cases. Currently, LLMs and Gen AI is in everybody's mouth. What can you think about Cumulocity and LLMs and Gen AI? What are potential future use cases you can see, or did you already experience with that? Do you already have some experience with that? How can customers can leverage from that trend, I would say?
Kanishk, I'll let you take this one because you have some hands-on experience there.
Yeah, I can start and you can add on later, Nick. So yeah, we have been investigating this topic for I think more than 1 year now. So we have an inbuilt team, Hallmark team, which is focusing on this particular aspect. That what are first of all the new developments in this generative AI world, and how is it, how can it enhance the IoT relevant use cases? So there we worked on different, we categorized our use case in different fields. So first of all, first example could be a documentation chatbot kind of use case, where it's a very basic retrieval augmented generation use case where you bring a Cumulocity, for example, a Cumulocity documentation, which is publicly accessible. You can train your chatbot on that particular Cumulocity documentation. And then with the help of natural language capabilities or generative AI capabilities, you can use that chatbot in asking certain questions from which are available in that particular documentation. So for example, please find how do I create a new device, or how do I create a dashboard to the Cumulocity. So this workflow will crawl the right page from that documentation. It will find the answer in the way that you want. So you can also have these enhanced natural language capabilities, like give me all the steps in bullet points, or explain me in a way so that even a 5-year-old can understand. So this is a very basic generative AI task that you can perform using these kind of workflows, which is already possible. So this is one topic that we explored. The second was how can we combine the generative AI or large language model with the IoT relevant time series data, or maybe some results coming directly from a machine learning model or predictive maintenance model. So in that case, that workflow, what it does is you can basically provide the answers coming, or prediction answers coming from a machine learning model, which is usually a time series data or maybe a JSON response. And a large language model can interpret that particular response in natural language. So can you explain me how this time series variation looks like? Can you find any anomalies and so on? So it can provide you the answer in natural language. You can also ask questions. Can you predict what is the energy consumption for the next 8 hours? So it will communicate with the right machine learning endpoint, find the answer, and provide you the answer in natural language. So these are some of the use cases that we have been exploring with different generative AI vendors. Of course, there are also some other use cases that can be beneficial. For example, code generation. So code generation can also be enabled by these generative AI platforms. So for example, we already have many microservices written in Python or maybe some other programming languages. So can you assist me in writing a Python code for this particular task, which I can use in my microservice and so on. But this is something we haven't implemented anything in that direction yet. But of course, this is also something that can be explored in the future. So yeah. I mean, there are many use cases which can be, leveraged or enhanced by these generative AI technologies.
Yeah. And there may be one point that I always like to stress a little bit to our customers is like AI is everything. Let's say is a very big universe, and generative AI, is just a very small part of that. And it's not a replacement for existing machine learning technologies. It's rather kind of an let's say additional layer that you can add on top of machine learning models to, for example, make the output of a machine learning model more understandable for a certain person. It's not like generative AI will replace all of the predictive maintenance algorithms that there are out there. It's just a kind of new what generative AI and large language models more specifically are very good at is that language part. It's about asking some things, getting a natural language response back, which is different from a 0 or 1 or a certain score output from a machine learning model. And so where generative AI is really or where we see it is generative AI augmenting things like machine learning to make the results of your machine learning, of your predictive maintenance, for example, more accessible for certain end users to interact with.
Yeah, I think in the last hackathon we explored with that exactly. You were also part of that, Kanishk, right? Where we had some wind turbines, and then we had some, wind speed and wind angle, some time series data, and then in the end we asked the Gen AI, is my turbine behaving optimal? How should I switch a turn around my turbine, my wind turbine, something like that? This was a very good example. I
think as Nick rightly mentioned that we cannot replace this, for example, anomaly detection model with a generative AI model. And even in that hackathon, we provided a small subset of the time series data or machine learning prediction results to that generative AI model or large language model. And we asked the question only about that particular subset. And in that way, it works really good because then you are limiting the scope of generative AI, which allows us, avoiding these hallucination kind of scenarios. So generative AI only referring that particular time series data, and it's only analyzing that particular time series data. And it is, converting the results into the natural language explanation. So this combination of a right source and the generative AI model can work very well. But of course, we shouldn't replace machine learning models or these analytics models completely with the generative AI model. Yeah.
But still, I think there's a bright future ahead also in terms of changing the way users interact with a certain platform more in a natural language way than having to click through certain processes, etc. Or also just support with documentation use cases. I think Kanishk mentioned the example of leveraging the Cumulocity documentation to just ask something in natural language and then get a response how I can do something with Cumulocity. But taking that one step further to let's say more customer oriented use cases, you could think of, instead of linking it to the Cumulocity documentation, customers could link it to their own machine documentation on how to use a certain machine or how to configure it. Maybe think also about error codes. Where
status codes is the most important stuff, I would say.
Exactly, those kind of things. And so if you could leverage a kind of large language model on top of that kind of machine documentation, status codes, error codes, you could also make it much more accessible to end users via the Cumulocity platform to do some kind of remediation or understand what is going on and then go into a certain corrective action based on all of that contextual information that you've gotten now, that not only looks at the data that you get from your machine, but contextualizes it with the machine manual, with error code manuals, etc., in such a way offer a more holistic experience towards end customers. That's where I also think that the combination of Cumulocity with large language models can really bring added value towards end customers of smart equipment makers.
Yeah, great. I asked everything actually I wanted to ask. This is your chance to actually share anything you still wanted to share with machine learning Cumulocity. Anything that we missed you wanted to talk about?
I think we covered many topics.
We did.
No, I think maybe just as a key takeaway, the important things to remember is that you have indeed, Cumulocity is not necessarily the platform in which you build your machine learning models, but it's the platform that is really, let's say, the link between your devices and machine learning models in making the data available for, on the one hand side, the training, but also on the second hand side, when you really want to use your trained machine learning model in practice, then you can also make the new live data available towards those trained machine learning models in such a way really drive the value of that machine learning model to make your use cases smarter, like we talked about the predictive maintenance use cases, anomaly detection, etc. So I think that's maybe an important takeaway for the listeners.
Yeah, maybe in addition to that, what Nick said, so Nick and I have been working on this topic for the last few months or more than 1 year, and we have been documenting all the progress on our tech community. So maybe people who are interested in, please keep an eye on tech community. We have been documenting, and in the future, we will also be producing many more such articles, which can give you more ideas about how Cumulocity and machine learning can work together for different use cases. That's just one message. Yeah.
I will link the existing community articles and the tag in the video description, so everybody can follow the links and read the articles if they're interested. Okay, thank you guys. It was a pleasure talking to you about this exciting topic. It went pretty good. Thank you again. Talking to you.
Yeah, thank you so much.